Hello, I am Professor Claudio Peruccio. I am Scientific Advisor of SBM Sistemi. We have been working in cooperation with 3 internationally well-known veterinarians involved in ocular surface study and research. 2 in the States, David Meggs from UC Davis University and Federica Maggio of Tufts University in Boston. And in Japan, Akito Saito, working in Tokyo at the Triangle Eye Clinic. I'll make a short introduction to the OSA VET handy manual. For an in-depth examination of the ocular surface, besides the usual procedures, it's possible to perform meibography and interferometry by an handheld instrument, the Ocular Surface Analyzer, OSA VET, made by SBM Sistemi. This is a schematic representation of the ocular surface tear film integrated functional unit. Tear homeostasis is achieved reflexly by the lacrimal functional unit, which consists of the ocular surface, the connecting innervation, the secretory appendages, the lacrimal glands, meibomian glands, and conjunctiva goblet cells. The trigeminal innervation of the ocular surface epithelia provides the afferent limb of the feedback loop. The parasympathetic secretomotor innervation of the lacrimal glands, meibomian glands, and conjunctiva goblet cells provides the efferent limb of this loop. In most animals, the lacrimal glands lie over the superior temporal part of the globe and within the stroma of the third eyelid. Their secretion of water, electrolytes, proteins, and mucins form the aqueous component of the tear film. Mucins are secreted by the conjunctiva goblet cells under autonomous nervous system control. Inflammatory mediators may stimulate mucin secretion and interfere with tear film stability. Meibomian glands produce an oily substance that is released in the eyelid margins and spread on the tear film thanks to blinking to form the superficial lipid layer. It's composed of polar and non-polar lipids, giving stability to the tear film by decreasing surface tension and limiting evaporation of the aqueous component of the tear film. Changes to the composition or production of lipids or mucins alter the tear film stability and increase tear film evaporation. Red, wet eyes are a frequent finding in animals presenting clinical signs of evaporative dry eye. A decreased tear production is particularly frequent in dogs affected by aqueous deficient dry eye. The cornea becomes opaque and vascularized. Conjunctivitis, mucus discharge, and crusty eyelids are common findings, and in several cases both aqueous deficient dry eye and evaporative dry eye are present. An accurate assessment of each individual case allows to choose the appropriate therapy. For the differential diagnosis of ocular surface disorder, it's mandatory to examine the meibomian glands by non-contact infrared meibography and the tear film by interferometry. Something we can perform by using OSA VET. An accurate diagnostic protocol should also include non-invasive breakup time and ocular surface topography by Placido disc. The infrared light emitted by the instrument allows to check meibomian glands along the eyelid margins to define their arrangement, density, more or less regular distribution, and morphology. Distichiae and ectopic cilia are easily located. In case of meibomian gland dysfunction, it's possible to pinpoint areas of glandular atrophy and loss. By interferometry, OSA VET lets us directly see the tear film lipid layer in order to define its thickness and kinetics over the tear lipid components, with the possibility to focus on important parameters like tear film composition and evaporation to make an in-depth diagnosis and choose the most appropriate treatment. We can also evaluate the meniscus height, the non-invasive breakup time, and the ocular surface topography by Placido disc. To learn how to use the OSA VET, you may follow the video step by step. A short training period is then necessary to make experience and achieve the best results. I am used to examine meibomian glands by meibography in all cases of red wet eye to confirm the diagnosis of evaporative dry eye due to meibomian gland dysfunction. By interferometry, I examine the patterns and kinetics of tear film lipid layer to better understand the tear film composition and dynamics. This way, I am able to make a detailed diagnosis and to choose the best treatment for each single case. Something I wasn't able to do before using the OSA VET, but is an instrument I can recommend to every veterinary ophthalmologist.